QL stuff. I just started up a new gig at Prisma. So Prisma is like a database toolkit company. You may be familiar with them from like other stuff that they used to do, like GraphQL is what they used to be called, and that was like they provided like a GraphQL hosted database kind of thing. And they've gone through some evolution, but Prisma now it's like a database toolkit. So like kind of like an ORM, but with a lot more capability and stuff, and gives you a really easy way to do databases with TypeScript. So that's what I'm doing day job wise now. I've done a lot of consulting before, building apps for companies. I used to work at Auth0, and at Auth0, I learned like tons of stuff about authentication and identity and all that kind of thing. And I've recently wrapped that up, that kind of knowledge, into a course that is specific to authentication and security stuff in a React application. And so Matthew knows me from that. He's been in the course that I put out. It's reactsecurity.io if you want to check it out. So yeah, I've got some free course stuff there. I've got some pro courses, and there's just a big focus on security for React applications. And that's, I think, what we're going to chat a little bit about today.
No.
Yep.
That's a wonderful introduction, and congrats on the new job.
Thank you.
Yeah. So kind of touch base a little bit about like just the base experience of Lambda students working with authentication and security in React applications, both on the front end and the back end. And I think it would be a great place to start the discussion on like, why should we care about security in our applications? As a base point for the,
Yep, I think that's a great starting off point. Security, it's an interesting concept and an interesting thing. My thoughts about it, have evolved from my time working at Auth0 and since then, building apps for companies that care a lot about security. I've built some apps like in the political space, and that's like a hot space right now, security wise. There's been a whole bunch of stuff going on in U.S. politics, security breach wise. So security is interesting because it's something I think that is never really done. You're never really going to ever come to a spot where you're like, okay, security in my application is now done. I can go think about other things. But that being said, for most of us, when you build an application, you kind of have to come to a point where you've got to stop at some point. Like you could go on forever and ever, like adding additional layers of security, being paranoid about whether your app is secure or not, continually testing it and all of that. But there is a point, even though security is never really done, that you kind of have to at least say, okay, I'm satisfied with the security state of my application. And so that kind of brings us to this place, I think, where there are some really key points that we can spend most of our efforts security-wise, focusing on security, and thereby we can know that like our applications are pretty secure. I think that's at the end of the day, that's where we can hope to get to, is a spot where we are pretty satisfied with our security, but we shouldn't ever be complacent with our security posture, because that is kind of a recipe. That's like the initial stages of becoming insecure, is when you start to become complacent. So yeah, like what can we do to be security conscious where it matters? I think what it comes down to, especially if we're thinking about building applications for the web, is making sure that our data that goes into powering our applications is securely protected. And so that is one area of focus where you can start to be modestly satisfied that your application is going to be secure. And the issue, I think, especially these days, is we're building out single page type applications, or I guess maybe for lack of a better term, like applications that predominantly run in the browser, is that a browser-based application in and of itself doesn't have any security, and it can't have any security. And that's because browsers are public clients. So like you, I'm sure, know in your studies, you just open up DevTools and you can see the code that powers the application. You can see everything that's happening over the network. You can fiddle around with things in DevTools and modify stuff. And so this brings up the point that it would be nice in some scenarios to it would be nice if it were the case that the application that runs in the browser, if it weren't accessible to, like, the underlying code that powers it, if it weren't accessible to users. So I get questions all the time, like, how do I actually prevent users? Is there any way to prevent users from opening up dev tools in my application? That's a common question. Can I stop them from going and getting the source code for my app? And the answer to that is no, you can't do that. Then the question kind of comes up, well, if I can't do that, is there a way that I can at least protect my code? Maybe I can obfuscate it. Maybe I can minify it and do all sorts of things to make it unreadable and whatever. And you can do that. That might give you some value in some ways. At least your code bundle will be a little bit smaller. But at the end of the day, anyone who kind of knows what they're doing is going to be able to just unminify your code and kind of repopulate values based on their best guesses, values for like what a function name is, for example, and be able to read your source code. So we have to accept this limitation that anything that runs in the browser is by nature free game for anyone that comes to your application. So security can't really happen in the browser itself, but it can happen on the server when you are where you have endpoints that are protecting or should be protecting data that should be accessed by your front-end application. So what this boils down to is you shouldn't ever really keep like secret information or data or things like that in the code bundle that you ship to the user. Instead, you should have your users you should make it so that they need to access that data from your endpoints on your server, because your server is really the only place that you can actually enforce and be sure that you've got a secure situation going on. So I think that's where security starts for browser-based applications. I assume there's a lot of work going on at Lambda School with React, and with React specifically, I mean, there's certain things you can do, like you can use these patterns like lazy loading, for example, to try to limit the portions of code that end up in the user's browser. So a user might come to your application and maybe even before they log in, maybe they don't even get the React application code at all. Maybe they just get like a sign-in screen. And only after they've authenticated and proven that they are who they say they are, then at that point you would send them the React code to power the application. And then you could send them just pieces of it at a time, right? Like maybe you would send them a piece for the dashboard first, and then if they're trying to get to a route that is only accessible by someone with elevated permissions, maybe you run a check for those permissions before releasing the rest of the React code. But all of that is really just kind of it's really just a band-aid approach. It's not one that's very defensible at the end of the day. There are many ways to hack around that. So I think that's mindset-wise, that's what to be super aware of, like off the bat, is that when you're in the browser, nothing is secure. The same holds true if you're moving over to something like React Native or any kind of native application that runs on mobile too. There are ways that people can decompile the application and get in to see the application code that goes into them. And the situation there can largely be the same. So the sensitive bits of your application, it's often the data that goes into powering it. And I think the key message that I always try to drive home is that you need to just think of your application as itself insecure, and you need to keep anything that should be secure on your back end. That's focus number one, I think. And then, security wise, there's a whole other set of things we could talk about. There's like all sorts of exploits that people can try to levy in your application, things like cross-site scripting attacks and cross-site request forgery. You definitely want to be sure you're guarding against those. We could get into sort of the details of what those look like if it's of interest. And
I think
go there.
I think our audience would really enjoy that aspect. And I think this is a great segue and a great jumping off point, right? So maybe as a first topic, just talking about local storage.
Sure, yeah.
Some of the pros and cons there, maybe tying that into some of the cross cross-site scripting attacks, and then why you believe that local storage is not the optimal solution. And then just a background for everyone else. Like one of the major bites for me for joining your course was don't store tokens in local storage. And that's what I had been doing for months. And I didn't realize the vulnerabilities and the access that I was giving to potential hackers. So maybe start with there and then see how we can progress.
Cool. That sounds good. I guess maybe to preface that point, when we're going to talk about local storage in this capacity, and when this topic comes up, most of the time it has to do with where you store your JSON Web Tokens. JSON Web Token authentication being a very popular way to protect your API and your application these days. It's not the only way. There are other popular ways to do it. One of the more tried and true, I suppose, ways to do it is with cookies and sessions. That's kind of the way that it was always done in the past before, the early 2010s, mid 2010s, when JSON Web Tokens really started to gain a foothold. Still a perfectly good way to protect your application, maybe even in some instances, a better and more secure way to do it. But if we're using JSON Web Tokens, chances are in your career that you're embarking on here, you're probably going to do that. You're going to be working on an application at some point that uses JSON Web Tokens. That's kind of just a fact of life now. And what do you do to store those tokens? I guess maybe why do you need to store them anywhere? We could start there. If you think about like a traditional round trip application, every move that you make through the application, every time you want to go get new data or a new page, or you want to navigate around, there's a request that goes to the server, and the server is going to calculate a bunch of things, and it's going to check if you're authenticated and do all sorts of work, and then string together some HTML to send back to the client. And that's what's going to populate what the user sees. And because there's that round trip nature happening, the spot where these decisions about whether the user can get access to certain data or certain page views happens in a secure location. It happens on the server before the user gets a look at that. And this whole setup gives us, if we're using cookies and sessions with this setup, it gives us a way to give this like persistent authentication experience where like a user can close the tab and come back to it and log in again. And we've all seen this, like you close your browser, you come back and you're still authenticated. When you're doing JSON Web Token authentication, it's kind of flipped a bit, where the token is going to go from your client, which is maybe the browser in this case, to your endpoint, and it's going to be verified there. And if it's good, resources get released, etc. And if you are going to do that from your browser, you're probably going to want to provide something that looks like a typical session, a typical cookie and session interaction, where you can have that persistent authentication feel. You don't want your users to have to log in every time they come back to the browser. So this means you need to keep your JSON Web Tokens somewhere in the browser. That's where it will be persistent where it will survive like page refreshes, where it will survive the browser being closed and reopened, etc. So local storage, relatively new feature in browsers, that had kind of emerged in the mid 2010s as like the optimal place to put your tokens. And in fact, when I worked at Auth0 initially, I started there in 2015, mid 2015. That was the recommendation at the time. It was like, if you want to have this persistent kind of session feel with JSON Web Tokens, put them in local storage, just pull them out of there when you need to send them to your server, and you're good to go. But concerns started to come up in the community and elsewhere that like your JSON Web Tokens, if they're in local storage, they become susceptible to cross-site scripting attacks. So what is a cross-site scripting attack? That's when someone who is interacting with your application or your website is able to supply some input to it that gets persisted, say, in a database. You can think of like, any kind of form, anything that like takes user data. If that user data is supplied and then is re-rendered to other users in your application, so maybe it's like a forum, that's a good example, like that. This is a commonly seen thing in forums. If the value that a user supplies is re-rendered in that forum, and it's not escaped. What you can get is the user can supply a script that gets executed in other users' browsers. So instead of me supplying a message, I might supply a script tag, and I might try to get that script to run. And it's actually fairly easy to get it to run. Like you could do something where you've got an image tag. That's a good way to execute one of these attacks. You've got an image tag, and you point the source to just nothing, or something invalid. And the image tag has this attribute called onError. And onError is going to give you a spot where you can run some JavaScript if there's an error encountered. And if there's no actual image resource found in the source, you can run that code. It'll just automatically run that code. So if you're not escaping those image tags or any input that the user supplies, you can get code to run in other users' browsers. So you, as a user of that forum, you supply a message that's got this attack, and then anyone who's looking at the forum can have it executed. And so because local storage is scriptable, you can access it through JavaScript. It's really easy to have a user supply a cross-site scripting attack that goes into the user's local storage, pulls out their token, and then sends it to some remote location. Maybe like the attacker's got a remote server where they're collecting these things, these JSON Web Tokens. And because the JSON Web Token isn't tied to that user specifically, rather it's just like it's like a key. It's a set of keys that says that the sender should have access to some resources on the server. Because of that whole arrangement, the attacker can then collect all these JSON Web Tokens and then just use them at your API. They can use them to get access to resources on behalf of the users who should have them. So you've got the situation now where an attacker might be just collecting tokens out of local storage. So that begs the question, like, well, where do you keep them then? And there's two approaches that are more popular these days that help to mitigate this, I think. I don't know if they're more popular. I think it's still really popular to use local storage. And there's an argument to be made that local storage can be used in a safe manner, and maybe we'll get to that in a second. But the other popular approaches are you can either keep them in an HTTP-only cookie, your JSON Web Tokens, or you can keep them in browser memory. So why don't we dive into those two? There's some caveats with each. We can chat about them. We'll talk about maybe the cookie case first. So cookies, if you're not super familiar, I wasn't super familiar with how cookies even worked for a long time, or how they got set, or what the situation was with cookies really. But a cookie is, the way that it operates at the end of the day is it's just a header. When you want to set a cookie in the user's browser, you will include a header in a response to an HTTP request that says set-cookie, right? So a set cookie header with a cookie value is going to then set that cookie in the user's browser. And the way that browsers work is they are just going to automatically include cookies in requests to the domains from which they came. So if you've got a domain of myapp.com and it sets a cookie in the user's browser, any request that gets made to your API, your domain, as long as it's living on that domain, the cookie is just automatically going to go there. That's just browser behavior. So what you could do is you could put the JSON Web Token in a cookie, and then you could have it sent along in the header, the HTTP header, automatically. That way you could then pick it up on your server and pull it off of the cookie and verify it that way. So the key to this is you got to use an HTTP only cookie. And that's to get around this cross-site scripting vulnerability. With an HTTP only cookie, it's one of the attributes that a cookie might have. It means that client-side JavaScript can't read it. It limits the browser's ability to go in and read it with JavaScript. Instead, it's only usable in HTTP requests. So that's cool. That's a way that you can mitigate cross-site scripting. But once you do that, you've got a bit of another can of worms that opens up, and that's that you're now susceptible to cross-site request forgery, CSRF attacks. And so cross-site request forgery is when someone makes you, as a user of an application or a website, they make you send a request to the back end of that website and perform some action without you even knowing about it. And this gets into that feature of browsers and cookies and the way that they work, where a cookie is automatically going to go to the domain from which it came. So if I were to send Matthew, let's say, like an email that had an image tag pointing to his bank's website, and I had some parameters in there, perhaps that said like, send money from Matthew to me, what I'd be hoping for is that he's logged into his bank's website as he opens that email. And he's going to open that email, and the image, because it's an image tag, it's going to try to make that request. And if that request goes, it's going to send the cookies to that domain, because that's the behavior of the browser. And if that happens, is, assuming we know the internals of how the bank's API operates, we can effectively get him to send money to me without him even knowing until he goes and checks his account later. So that kind of sucks. But CSRF attacks, they're maybe a little bit more difficult to carry out. You have to really know the internals of like the API that's being used at the application you're trying to attack. It's not as feasible perhaps, but it's still a danger. So it'd be nice then if we didn't store the JSON Web Token in local storage or a cookie at all. This though opens up the problem that if we do that, if we aren't storing it, we've got no way to make that sort of persistent authentication login session kind of behavior that we're talking about. However, there are some ways around it, and one of the kind of more popular things to do, I think, these days that I'm seeing, and Auth0 advises this, is to store the token in memory, in the browser's memory. In a React application, this looks like just storing it in your application state. So you could just set state as your token comes in. And then you use it in your request to your backend. And then the user goes to refresh the page and they lose the application state. So that sucks. They have to log in again. But what you can do is you can use refresh tokens, which are a different kind of token than your typical JSON Web Token, to get a new JSON Web Token whenever the application loads. So the user closes the application, comes back to it later. As the application is loading up, perhaps before it even renders, it's going to try to use a refresh token, if there is one, to get a new JSON Web Token. And the refresh token itself can be stored in a cookie, an HTTP-only cookie, like we just talked about. And because of the way that a cross-site request forgery attack works, the attacker can never get the response from an attempted request. So the attacker so me as an attacker, I might try to get Matthew's bank to send me money, but I'm never going to see the response that comes back. I'm just kind of blindly trying to get him to send requests to his bank. So what that means is that even if someone were to carry out a cross-site request forgery attack that gets my browser to send the refresh token to get access to a new JSON Web Token, at the end, I'm never going to be able to get that response. I'm never going to be able to get that JSON Web Token back, which means, relatively speaking, at least in many people's opinion, that's a safe way to kind of have your tokens arranged. Refresh token in an HTTP-only cookie, JSON Web Token, which is the one that's used to get access to resources at your API, stays in memory, and then you just refresh it every time the user comes back to the application. And Auth0 does something like this. They advise something like this, where when you are going to store your tokens in the user's browser, you keep them in your application state, and then when the application is refreshed, you do like this. They have this mechanism called like silently get a new token, and it uses this background kind of process through an iframe where there's a request made to Auth0, and there's this whole cookie and session setup with Auth0 where you would have a persisted sort of Auth0 session, and if that session is still good, then you would get a new token. That case is more concerned with like how a third-party authentication provider like Auth0 would operate. It's not really the typical one that you would see if you're setting up your own authentication. However, it's the same pattern in the end, where you're just storing in browser memory, and then you're refreshing as the application is reloaded. So there are lots of ways to do this. And some would argue that local storage might not be that big of a deal at the end of the day. And that's because if you are worried about cross-site scripting attacks, which I think you should be, I think that there's, you should definitely be worried about having a cross-site scripting attack, having that be a possibility on your page. But if you're going to protect your application at all, you should be protecting it against cross-site scripting attacks. And if you're protecting against cross-site scripting attacks, then you're probably okay with having your tokens in local storage. You wouldn't, I guess you would say, like, you wouldn't ever like not store your tokens in local storage. You wouldn't ever say, okay, I'm going to not store them there and I'm not going to worry about cross-site scripting. Now that my tokens are out of local storage, I don't need to worry about cross-site scripting attacks. You wouldn't want to do that because there are many more things that someone could do with a cross-site scripting attack, right? Like you could supply, as an attacker, you could supply some JavaScript, which is just going to make requests on behalf of the user, sort of in the background, and then get the results from those requests and send them to some remote location where the attacker could be collecting data. So if I get some cross-site scripting on your page, I might act on behalf of the user, sort of in the background, unbeknownst to the user, just like making HTTP requests, getting data, and then sending that data to my own like storage spot somewhere, right? So that's a possibility. So all that to say, like, I guess to sum it up, it would be like, if you are going to have good security, good hygiene in your application where you're guarding against cross-site scripting, then maybe it's not a big deal to keep them in local storage. But be aware that if there is an attack vector there, if cross-site scripting is a possibility, it's going to, you've then got a surface area. If you're keeping your tokens in local storage, you've got this surface area that makes it a bit dangerous, right? So anyway, those are some thoughts there. How's that, Matthew? Is that?
I think that was way more than some thoughts. That was really well expounded upon. And yeah, that's phenomenal. This is all really insightful to us because we've handled a lot of it on the surface, but kind of one of those things where we've gone a mile wide and only an inch deep. And This is a really good job of kind of just giving some breadth as to what are the other concerns and implications. And I think part of our jobs as engineers is to understand the trade-offs, understand what the implications are of using X, Y, or Z, and then being able to kind of justify why we're going to do whatever we choose. I guess my next question for you, and kind of my last question, is if you're going to create your own website tomorrow, how would you be handling your state? Would you be doing third-party auth, or would you be handling it yourself? What would be your go-to?
Yeah, that's a great question. So my go-to, I'm biased, I'm sure, because I used to work there, but it would be to use Auth0. I left Auth0 in late 2017, and I went out to do some consulting on my own, building applications for companies and for startups. And I just relied on Auth0 for the authentication pieces. And there's a few reasons you might want to do this. One of the concerns that you will have as an application developer if you build your own, it's the typical question. It's the $1 million question: build versus buy, right? It's like, do I invest the time building this out myself, or do I just pony up some money and have it taken care of for me? There's trade-offs all around in this scenario. But if you are building on your own, there's a whole layer of very security sensitive stuff that you've got to worry about. So you have got to worry about keeping dependencies up to date. You got to worry about the changing landscape of security as a whole, like just out there on the web. Browser behavior changing, like Chrome recently introduced, and I think all browsers might be doing this now, changes to the way third-party cookies are handled. That actually created a breaking change for one of my clients' applications. We had to deal with that. All sorts of stuff like that you've got to be concerned about. And even if your code never changes, you are going to still need to be worried because the world around your code is always in flux, right? There's never a static situation. You can never be complacent with security in that regard. so that's a big responsibility. That's probably more of a headache than you really want to have. So then you might say, okay, well, I'll go use a third-party provider like Auth0. It's their job to be very security conscious. They've got staff dedicated to making sure their infrastructure is secure, etc. Then you don't have to worry about doing stuff like salting and hashing passwords and dealing with features that don't add a lot of value to your core product. Things like password resets and, if you want to introduce multi-factor authentication and passwordless authentication and single sign-on and all these kinds of features that are not trivial to do properly and to do securely. And you can just you can think of the fact that like every time you introduce one of these features and build something that just handles this common task, there's like there are exponentially more problems that you will potentially have, and exponentially more security concerns that you're going to have. Like, it's not just a linear progression in that regard, I don't think. So, excuse me, you might want to delegate to Auth0 or something similar. There's lots of these now. Auth0, Okta, Firebase Auth, what's Amazon's? Cognito, I think. Lots of these different providers, right? And so what are the downsides of using a provider? Well, maybe we'll start with the upsides, actually. The upsides would be like you've got, like I said, a company that is dedicated to security. That's good. You've got a faster track to getting going in your application. Like with Auth0, it's very simple, especially in a React application. And I go into this in my course using one of their newer libraries for React. It's like this React Hooks SDK. Man, it's so simple. It's like so much simpler even than like when I worked there a couple of years ago. You can get Auth stood up in your application in an hour if you look at the docs or if you do a course or whatever. So it's fast. It's very fast. You get a login box right away. You're good to go. You got a user management area. That's another thing. Like if you build your own Auth, you've then got to build your own user management area, right? Not super simple. So it's good for that. They've got great APIs. You can manage everything you need to. Everything's kind of done for you. The road is paved. The recipe has been set. So that's really good. Downside is then you've got to pay for it, likely anyway. There's lots of these providers that give good free plans, like Auth0. I think it's 7,000 free users, 2 social providers, all for free. You don't have to pay anything to use it. So that's in that way, like you can run it in production without it costing anything, and you still get all those security benefits. And then there's others. I just saw a tweet. Somebody tweeted me, I think just yesterday, saying that I forget, is it Firebase or Cognito? I can't remember which one, but they give you 50,000 free users. So that's pretty decent.
Yeah, it's significant.
And yeah, very significant. Like you can run a whole business, without needing to pay anything for authentication. Another downside though is that if that service experiences issues, then your application can experience issues too. I had this with 2 of my clients. Auth0 had an outage, I think it was a year and a half ago or something. Had an outage in their, what was it? One of their deployments, one of their like self-service, like Auth0 split up into like their enterprise kind of service where there's a certain deployment model for enterprises that are using Auth0, and then there's like if you're a self-service user, like you just go in and you pay 20 or 60 bucks a month or whatever, or if you're free, you're deployed somewhere else on AWS. Anyway, they had some outage, and so my clients in their office and all of their users using their third-party app, they couldn't log in for a few hours. So that's disruptive. Like that sucks. That's not fun. So there's that reality that you might hit issues like that. Auth0 though, I mean, they know that. They know that if they go down, then their customers go down with them. So they are investing heavily, and they have been, in making sure that uptime is where it needs to be, right? So there's that downside. There's a few more too, but I would definitely still go. All things considered, I would definitely still go with a third-party provider. And for me, it's Auth0, but I might try something else out in future iterations and other projects that I embark upon.
Yeah. This is all great information and super insightful. My last question for you would just be: we're all kind of entry-level developers, just kind of getting into the industry. Is there any kind of insider advice you'd like to give us, or that you would give yourself when you first got started as a software engineer?
Yeah, for sure. So one thing that I always advocate for, and so like I'm sure you've seen this, Matthew, is like I put a lot of content out and a lot of video stuff. But I don't know if you've seen it in my written stuff, but there's a lot of written stuff as well. And you're in training right now. You're going to be going out and getting jobs at some point in the near future. And I think it strikes me that Lambda School's got a particular model where hiring is maybe not a huge concern, because like there are paths into various companies and stuff like that. I don't know how it works, but that's what I see online, which is great. That's awesome. I would say to enhance that, to make yourselves attractive on the job market, to further your journeys as developers, one thing you might want to think about is putting content out into the world. And what does that look like? That it can take many different shapes, but one of the best things I think you can do, that I advise most people who are getting started to do, is to do a blog and to talk about what you're learning, to do it in a way where you're teaching people what you're learning through tutorial form, through blog form. And you're going to get a few benefits from that. You're going to get something that's going to help reinforce your learning, because when you teach others, it just inherently helps to reinforce what you've learned. And it will give you a portfolio of stuff you can point to that shows work that you've done. It will also help get people's attention, because if you promote this stuff, people obviously, like we all know, they really need tutorials. They really need content. So that's I always advise to do that. That was kind of my foray into the tech world. I used to work in government, and I didn't do any kind of boot camp. I was close to doing a boot camp, but through just learning on my own and doing blog posts and getting into tutorial sites and stuff like that, I was able to actually get that job at Auth0. That was my first job in the tech industry, just by spending time learning on my own, teaching what I knew, blogging about it, putting it out there into the world. That led into this career that I'm at now, where it led to a job at Auth0 and has led to where I'm at now. So I definitely always strongly advise putting content out there. Blog if you can, do videos if you can. Always helpful.
Cool. Thank you very much. We really appreciate it. I want to take just one last minute to give a quick plug for your course.
Sure, thank you. Yeah, so it's reactsecurity.io. What I'll do, I'll just grab a link here. This is the, I'll put two links. This one is like the advanced course that I just released. And the second link that I'll put in is just the main kind of landing page for React Security. And that's going to get you, situated well, I think, with security and authentication for React applications. And I just saw a comment. Is there time for questions? I'm happy to answer questions. I got some time here if you want to. But just wrapping up on the React security stuff. That's if you want to learn more about security and React apps, there's lots of stuff there. There's a free course and there's a pro course too. So check it out.
And just a little testimony, I've done the free course so far and just starting with the pro course, and highly recommend it. Great content, easy to follow. So
thank you.
Awesome. Yeah. So right now, the way the Zoom's set up is that you can unmute yourself. So if you have a question, you just want to raise your hand in the little Zoom thing, and we can take a few questions until Ryan has to go.
There's one in the chat here we can start with, I think. Hey, GDPR concerns for refresh tokens. So I'm not super well versed with GDPR, but I think that it has to do only with like if you're storing data about the user or something like that, right? Like I think that's the primary concern of it. I remember reading something about this, like if it was concerned with cookies, but I don't think it is because you're not using it to store user data. I could be wrong, so don't quote me on that. But I don't think it's a big concern. Index DB versus local storage. To store a token, I suppose that's possible. I've never seen anybody use index DB over local storage. I don't think it's the model that would necessarily bode super well. But that's interesting. I wonder, like index DB, maybe it's accessible by JavaScript. Well, it must be, right?
Yeah, real quick, that was my question. And the question specifically was more about the security differences between local storage and index DB, if you know anything about that.
Yeah, I don't, unfortunately, with index DB. I like local storage. I know mainly that it's susceptible to cross-site scripting. But that's interesting with indexed DB because that's the DB that runs in the browser, right? So that's yeah, it must be subject to similar constraints or similar concerns then, if it's like something that's scriptable. I would just make sure that if you're wanting to use it, just your main concern, I think, would be like whether or not cross-site scripting is going to be an attack vector, right? Like if somebody can just like pop a script onto your page and do like I don't even know how it's accessed with code necessarily, but like you'd want to see, like if you can access it with JavaScript, you'd want to make sure that cross-site scripting is protected against for sure.
Yeah, I think it's very much the same thing. It's more like a database that is local to your local install. So I would expect that it's got the same pitfalls without some of the limitations of local storage. Okay, thanks.
Yeah, you got it. Next one was Passport.js does not take responsibility in case of breach. With that in mind, what's your opinion? So Passport.js, yeah, that's right. Passport.js is a library that you can use to like ease the whole like OAuth. Well, there's lots of different things you can do with Passport, but one of them is like you can do OAuth, which we didn't have time to get into today. It's all about like it's all about what would I say? Being able to get access to resources in a limited fashion based on some login that you have at like a social provider, for example. Anyway, Passport.js, they don't take responsibility, no, but they are an open source project, which means that it's got a lot of eyes on it, making sure that it is doing what it should be doing. But that being said, I think that the real sensitive pieces of Passport, or the real sensitive pieces that go into this whole thing that you would do with Passport, this whole thing being like authenticating a user, for example, or getting a JSON Web Token from a social provider, whatever, is kind of like downstream from Passport a bit. I think Passport is really just like a doorway to get yourself there, and then those really sensitive bits are the risk for those is assumed elsewhere, either at your own database and authorizing your users from your own database, or like whatever social provider authenticating users as well. So yeah, Passport, I think it's a good library to use. I've never used it in production. I've toyed around with it. The author of it used to work at Auth0, Jared, and he's a super smart dude. So I trust his work for sure. Explain why an attacker can't get access.
Thank you very much.
You got it.
Thank you very much, Ryan. I just want to say thank you for coming out and doing this talk. Security is something that we don't really get a lot of here in Lambda. And I understand the reason is because that's a whole other world and we will have to kind of do a separate bootcamp just for that.
Yeah.
But I think that if there's little simple things, like I understand that there's people out there that are very smart, and if they want to hack you, they will. Mm-hmm. But I feel like if there's little things that are obvious, to have them set up so that when we get hacked, we don't get hacked for something ridiculous,
Yeah.
So that we only get hacked for like the really crazy people. We're not an easy target. But thank you very much for doing this kind of talks.
Yeah, you bet. Yeah, happy to. Thank you. So next one, can you explain why an attacker can't get an access token with a refresh token? Yeah, so So they could. So this is actually this deserves some follow-up. This whole refresh token, access token thing. Refresh tokens are. This is a whole like hotly debated topic in the realm of security, because refresh tokens and JSON Web Tokens, OAuth itself, all of these things are kind of being used in a way now that maybe they weren't initially intended to, and mostly that's sits around this whole thing that we do now, where we build browser-based applications. We build applications that live in the browser, like our React apps, and then we access data APIs. We can use all of these things for that, but it's not exactly how they were intended to be used initially. The story with refresh tokens is that if you're doing, it's a concept that comes from OAuth, and it's been sort of like borrowed in non-OAuth settings now too. But the concept is this, that you get a refresh token and an access token when you log into an app. And your access token is going to expire at some point, and that's good. You want it to expire because you don't want it to live forever and forever be able to grant access to resources. But your refresh token can be used to get a new access token when desired. So if your access token expires, you can send a refresh token to get a new access token, and you're still considered logged into your application. So this is good, but it is also risky, because if an attacker got access to your refresh token, now they don't need to worry about a username and password. They can just send that refresh token into your authorization server to get new access tokens whenever. So they're dangerous in that way. At Auth0, when I first started there, we were showing people how to like keep a refresh token in local storage, but we came down hard on that, because that's like, for a cross-site scripting vulnerability, attack surface area, that's a big one. Refresh tokens in local storage. Like if somebody did get cross-site scripting into your page and they were able to get a refresh token, that's like the worst thing that they could get, because then they're just going to be able to mint themselves new tokens whenever. So that's no good. So a refresh token then, like where's a good spot to keep it if you don't keep it in local storage? And like I mentioned, an HTTP only cookie is a decently, and opinions vary on this, but it's a decently safe bet, because even though the attacker could make you send the refresh token, remember if it's an HTTP only cookie, they can't get access to it through JavaScript, because it's HTTP only, meaning that you can only send it through HTTP requests. The attacker could get you to send your refresh token, but they would never see the response. They would never see the access token coming back. So refresh tokens, we got to be really careful about. So hopefully, I'm not too sure, Tim, if that helps to answer that, but hopefully it does. Auth tokens, not JWTs, but store those in local storage. So I'll kind of just, for the sake of time, kind of hijack one part of this question regarding like sessions mostly. And sessions are, I think, a good way, if you've got an application where it's like just your React app and just your API, your first party API, meaning that like you're building a Node API, for example, and the only thing it's ever used for is to like for your React application to get data. In that case, cookies and sessions are a good approach. You don't have to worry about recreating the wheel with regards to like sessions in the browser, because that's what you're doing when you do all these things with JSON Web Tokens. Ultimately, you're kind of ending back up at that spot where you've recreated sessions. There's this article that I always link to where this guy is advocating for us to stop using JSON Web Tokens. I'll link it up here in the chat. Kind of a famous article where this guy's saying that we shouldn't use JSON Web Tokens. And the crux of it, like what it comes back to, is that if you're using JSON Web Tokens to get a good user experience, you basically have to recreate cookies and sessions. And why do that when you can just use cookies and sessions? And the reason why you might not be able to do that is because you don't always have control over like where your API lives and the domain that it lives on. And if you have an API that lives on a different domain, then you can't send cookies to it. Cookies only go to the domains from which they came. So that creates a scenario where maybe JSON Web Tokens are a good bet for you. And also, if you're like doing things where you're involving third-party APIs, if you're opening up your API to third-party consumers, so like integrations with other applications would be an example. JSON Web Tokens or some other kind of access token, that's probably how you're going to want to do it. So I guess like I'll go back to the top of that question, Devin. So auth tokens, not JSON Web Tokens, best to store those in local storage or as cookies. I mean, if you're doing cookie and session authentication, it's obviously going to be a cookie. If you're doing things like what is it, basic authentication or whatever, where you've got some kind of other token, it's kind of the same story as JSON Web Tokens. If the user can get access to it through cross-site scripting, it can be dangerous. So same kinds of things apply. Timeline for token expiration. So depends on the sensitivity of your application, I suppose. I've got an app where it's 2 hours for one of my clients, and I've got another one where it is 8 hours, like a work day, more or less. I'd recommend short expirations and refreshing them often, if that's a possibility. And if you're using Auth0, this is pretty doable. Auth0's default expiration, I forget what it is, but I think it's like a couple hours, if memory serves. It might be something like 5 hours, sort of the default they said. So anyway, I would say though, keep it to hours, not days, or certainly not anything beyond that, right? Encryption, what parts of this are valuable to encrypt? Yeah, encryption is useful on a few levels. I think, yeah, like I guess there's a few different spots we could go with it, but like your database should be encrypted at rest, as they say. So like your data should need an encryption key to be able to read. And if you're using like a managed database service, this is usually pretty simple to do. If it's running on AWS, they'll just like encrypt it with an AWS key and you're good to go. Sensitive data that you might want to encrypt, think about encrypting, would be if you're storing like access tokens to other services. So for example, like if you've got, if you have a user that logs into your application and they need to perform like an OAuth transaction to make use of their, I don't know, their Twitter profile through your application, you're going to get an access token for them, and you're going to need to store that so that they can keep using it later. And maybe there's like a refresh flow that gets set up, whatever it is, like whatever is the case with tokens that get created for that user, you should be encrypting those, because like you should be double encrypting. You should be encrypting at rest, but you should also encrypt the value as it's stored in the database and then decrypt it on the way out, if that makes sense. So it's like kind of this double encryption layer. Just a best practice, I think, for making sure that, because that's like the super sensitive stuff, right? When you're thinking about passwords, you don't encrypt passwords. You rather hash them. And hashing, if you're not familiar, like the whole password salting and hashing scenario, that's where your password, when it ends up in your database, should be this jumbled mess of characters that you can't make sense of. And the way that it's done, you can never work backwards to find out what the user's password is. You can only ever verify that two hashes are equal, the one that the user supplies, or the one that is produced by the password that the user supplies, that gets calculated after they supply it, and the one that has been stored in your database. You got to make sure those two line up. Concerns for server-side rendering auth. Excuse me. One concern is that, and I don't know if this is much of an issue anymore, but I know that at one time, it may have just come down to being like a documentation issue, but there was like some doc somewhere in React land that showed how to take like some kind of like data payload or something that was then serialized and sent back to the client or something like that. So like it was to support server-side rendering, if I remember correctly, but it was like so you could hydrate your page, something like that. Anyway, the doc showed like this way where effectively the user could supply some data, which would then be serialized and like rendered back, which created this opportunity for a cross-site scripting attack. I don't know if that's something that server-side auth sort of server-side rendering like as a whole, or if that was just a singular documentation issue. Something else server-side rendering wise that you might want to just be aware of is that if you're using something like Next.js, where they've got this, they kind of blur the lines between what is the client and what's the server. And so like if you're writing a Next app, you're writing a React code. And if you're in this particular method, you're going to be running code that's actually on the server before the client gets rendered. And then the rest of it's going to be on the client. So it's this kind of weird situation where like, what's the server and what's the client? And you've got some limitations there as to how this is all going to work out. In my course, we look at a way to handle the authentication in that scenario using cookies. Cookies is kind of like one of the easier ways to handle auth. You can't really, because you've got no concept of local storage, right? If you're in a server-side rendered scenario, like if you're on the server, there's no local storage. Thoughts on putting things like user's ID in JWT? Yeah, user ID is totally fine. The things you want to keep out of a JSON Web Token, because with a JSON Web Token, I don't know how much you've been looking at them in your coursework, but a JSON Web Token is not like it's a jumbled mess of characters that create this token, but it is not something that's like hashed and can't be worked back. It's rather just encoded, right? It's an encoded string, which means it can be worked backwards, and it's deliberate that it can be worked backwards, and the payload can be read. The payload of the token, it's this object, this JSON object, which can store stuff. And what you want to do is make sure that in the payload of the token, you don't keep sensitive things like the user's password or something like that, right? Like you don't want to store stuff that's really sensitive. You don't want to store anything that you wouldn't want your users to see. So a user ID is generally, in most cases, fine if they can see their own ID or if someone else can see their ID. In most cases, it depends how your database perhaps is set up. Like if you've got a situation where you are enumerating users as they are added to your database, like if you've got a field that just auto increments an ID, like an integer. So I'm user 2, Matthew's user 3, for example. In that case, you could have this situation where an attacker could start enumerating users based on that ticking integer. But if you got like a universal unique ID or some other randomish kind of thing, then it's not such a big deal. But there's a good chance you're going to want a user ID in your JSON Web Token. And that's because you want to be able to take that user ID from the token as a request comes to your backend, and then use that ID to make decisions about how to like do data queries, for example. Packages like DOM Purify enough to sanitize user input. They're enough to prevent cross-site scripting attacks. That's the library that I recommend using to sanitize data as content, I should say, as it's rendered to the screen. I'm sure, like for most cases, DOM Purify is good. I think that is one of the more popular ones, so I would recommend it. I've used it plenty and been happy with it. And that's the end of the questions in the chat. Any others from the group?
Yeah, I have one really quick.
Yep.
So if we were to do most research on our own, what types of attacks would you look into to learn how to defend? What are the main type of attacks that you would recommend researching on?
Yeah, great question. I think cross-site scripting for sure. I think if you're using cookies, cross-site request forgery. I will show you, I'll send this link to you. Maybe you've seen this, but the OWASP project, what does it even stand for? Something security, something, I guess. Anyway, they're kind of the go-to for stuff like this. They've got this like top 10 list of stuff you should be worried about security-wise in your application. And I'm even just taking a look at it right now. I think injection for sure, their first one. There's some on here where maybe it's kind of like this is stuff that used to be relevant, like number 4, XML external entities. Like, you know, I don't think a lot of us are using XML processors too often anymore. What else? I think for me, the biggest ones are like if authentication is broken, so if something is broken in the step where users have to prove that they are who they say they are, typically, traditionally it's username and password that does that. If that's broken, if they can, for example, supply the wrong password but still be considered authenticated, then that's not good. Access control, if that's broken, that's a big one. So if if you don't put a guard on a certain route that says the user has to be admin to get to that resource, that's a biggie. And then injection. Those are the big three for me. One that's interesting, I'm not sure if you're too familiar with GraphQL and everything going on around GraphQL, but one of the nice features of GraphQL is that you can introspect your GraphQL API. So you can see what kinds of actions you can perform at it or what kinds of queries you can make. And this is great for developer experience, but it also gives a situation where an attacker would be able to basically see what your API can do. So I just turn it off when I go to production. This introspection feature is just completely turned off so that can't happen. Anyway, take a look at this OWASP top 10. I think that's a good place to start. Okay, so good security library for Node React. I mean, it depends on what specifically, I suppose, you'd be looking to do. I think it ends up being a mix of things. So like, for example, DOM Purify for guarding against cross-site scripting. What else could you do? I mean, there's no real kind of libraries that are like, install this library and will protect you against all possible security vulnerabilities. It's more so like you've got to manage those things on a feature by feature basis almost. So yeah, nothing that's like global, but certainly for cross-site scripting, DOM Purify for things like authentication, Passport, as was mentioned, that's a good place to start. But beyond that, it's more patterns than anything. Like you want to make sure that you're enforcing patterns correctly, which in the coursework that I linked to, we definitely get into that. Plug and play prevent SQL injection. Yeah, like a plug and play thing to prevent SQL injection, kind of, but not so much. If you're using like an ORM, and check out Prisma for this. Prisma's cool because you are basically guaranteed that you can't make an invalid query, and you are kind of giving yourself the opportunity to really mitigate potential like SQL injection, right? You're using tools that help to prevent that. So check it out. Course link is pasted there, and yeah. Any others before we wrap up? I know we're just a little bit past our initial time that we set to be done by. All righty.
Yeah, that looks like about it. But Ryan, I really can't thank you enough. I appreciate it.
Absolutely.
Really, thank you for your time. Yeah, there's so much valuable information, not only in this talk but also in your course. So yeah, seriously, everyone here was super excited. I was excited that we had 20 people at the beginning of the chat, and we ended up getting to 90 people. So you've helped a lot of people here. I really appreciate your time, and wish you nothing but the best moving forward. Yeah.
Thanks so much, everyone. Appreciate you paying attention and listening to me talk. Let's hopefully do this again in the future. And best of luck with all your coursework.
Cool. Thank you. Bye.
All right. Bye-bye.
Thanks, Ryan.
Good afternoon, everyone.